the goal of this session is, well, first I'll start with my assumptions. My assumptions are that you've used Git before. Maybe you're using Git on a pretty regular basis. And my hope in this session is to get you more familiar with collaboration patterns that use Git as the version control system and GitHub as a system to facilitate collaboration. I do a lot of my work on GitHub. Probably, I spend a lot of time on GitHub, including to organize this event and to write software, which is what most people use GitHub for, but also to write articles and to write grant proposals and to write websites, which is also something that you can do with GitHub. So GitHub, together with Git, forms sort of the backend for a lot of my collaborations. And one of the benefits of that for me is that regardless of what I'm doing, I'm using the same set of patterns, the same set of workflows to do all of these things. I have muscle memory already of how to do these things, and I've developed sort of an understanding, at least somewhat of an understanding of how these things work to such an extent that I can apply ideas from my software, kind of like when I learn about things in software, okay, I can take that to like writing articles or actually recently we spent a bunch of time arranging how to design and produce conference posters automatically on GitHub. One of the cool features that GitHub has developed over the years is the fact that it's not just a backend for storing Git repositories, which it certainly is, but it's also very tightly integrated with a computational platform. In fact, it's running lots of computations for us on now that it's owned by Windows on Azure, so on a cloud computer. So it's also a cloud computing system. So hopefully we'll get to see lots of that today. My assumptions, again, are that you're a little familiar with Git. I'll start slowly by sort of starting a Git repository on my in my little corner of the hub, and then eventually we'll upload that. I'll use who here was here in this room in the previous session, the Python. Okay, a lot of you. Okay, so those of you who weren't, don't worry about it, but I will use the code that I wrote in the previous session now in order to demonstrate kind of like a realistic workflow of Git and GitHub, and try to integrate that together with software testing, and we'll see how far we get. Okay. So in this previous session, we developed a software library, and we have all this code, and it's stored in a directory on our hub. So we did that just before lunch. We developed some code, and this code does geometrical computations. So far, we've only developed one module. That module is called circle.py, and it does two calculations, one of area, one of circumference of a circle. So that all is fairly straightforward. It's some Python code. It's stored in some files, and it's natural for us to say at this point, we're looking at this now, that we'd like to track. So let's say we're happy with what we did now, and we're ready to track this with Git as a Git repository, and then put this on GitHub. Before we can actually start using Git and GitHub, though, we need to configure our environment. And so that's something that you all want to follow along with pretty closely on your side of the hub. So I encourage you to sort of follow along as I do the steps, at least these first two steps. And that's because we'll, of course, once we do these things together today, and hopefully we'll be able to sort of show some of the collaboration patterns together while we're working here in this session. I want you to sort of have hands-on keyboards to download the code, clone the code that I'm creating, make some changes, propose changes, then we'll collaborate together. And in order for that to work, we have to do two steps. Let me find this. It's inside of the shared info. There is a page called git setup.html. which tells you about how to set up your Git environment in the NeurAcademy Jupyter Hub. So there are two steps. One is about configuring Git itself to know your username, your user email. We're adding this configuration that when you create the first branch in the repository will be called main rather than master. And we do this kind of configuration of the pulling behavior of Git. So these are incantations that we will invoke here. So I'll do that along with you. So I'm copying Noah's thing. Okay, I'm going to go to terminal, start a terminal, cd into my home directory, and then I can copy over. But instead of Noah, we don't all want to be Noah. So I'm going to be me, and you'll be you. And then I'll go to get set up. I'll copy over this next command. These commands in particular are required because Git, when it makes commits in a repository, it needs to know your name and your email so that it can mark those commits as being done by you. And if you don't do this, the first time that you try to commit, it will complain and say, you haven't configured me yet. Who should I say did this work over here? And this one is good to do because it configures Git to call the default branch main. And this one's good to do because it specifies how pulling is done. Otherwise, when you first issue the pull command, and we'll see the pull command in a little bit, it'll say, I don't know what to do here. What do you want me to do? And so now we told it what to do. So that's kind of the first part here. So let's take a minute for you all to do that on your end. And then we'll... Yes.
So for like the polling specifications and stuff, isn't that what Git does by default? Or am I missing something?
Depending on the version of Git, you would get like a message that says, this is what I'm doing per default. Like every time you pull, you'll get this long message being like, this is what I'm doing per default, but you should configure me and specify this thing. So I think that's why we put this in here.
Is there somewhere you can see like all the options for different?
Yeah, there's ways to specify all kinds. So this, I should say, maybe if you want to know a little bit what's happening under the hood, this writes into a file. I have a git config file here, and this writes stuff into this git config file. And you can do this, you can configure many other things here as well. Did that answer your question?
I'm just wondering what where one might be able to see the different options available for.
Oh, for this, I think you'd have to go and look at the. Yeah, I think you'd have to
know what we're able to configure and what are the different ways in which they can be.
Yeah, I think you'd have to look up the documentation, the Git documentation for all the various things. I don't know them.
All right.
Okay, I see people still typing, but you can kind of make eye contact with me when you're done with this. If you're done configuring, the next thing in this document is to configure your SSH, an SSH key. the idea behind this is that we will be communicating with the GitHub website. And when you communicate with that website, or with other kinds of web services or remote computers, you need to authenticate in some way. Often you'll enter your username and a password, and that will then the other computer will know that you are who you claim to be and will let you in. GitHub actually doesn't support that way of authenticating. It used to do that. It used to be the case that when you tried to push something to your own repository, they would ask you for a username, password, and would let you in. Now they don't support that setup, that way of authenticating. Instead, what there are a few different ways of doing this, but I think the one that's most appropriate for the setting that we're working in, and for most settings actually, is to create an SSH key. The idea is you have a key on your computer on the computer that you are on the hub, stored somewhere in your home directory, and that key is made out of two parts: a private part that's only stored on your machine, a public part that you can share with various services that you want to authenticate against, like GitHub, for example. You can tell them, here's my public key, and then whenever you're authenticating, basically a handshake happens, and the public and private key are sort of authenticated against each other. That lets GitHub authenticate you without you telling them your private key through the magic of cryptography. At any rate, we will do this in a few steps. First, you generate a key. This is this step here. I won't do that because I've already done it. Use the email that you used up here. This will store, and it'll ask you, where should I store this? The default location is in your home directory, /home/jovian/.ssh. There's an SSH folder in there that stores those kinds of things. And just do that. It'll ask you for a password. You can just press enter twice to say that you don't want password. Since it's not going to be accessible to anyone but you through this location, it doesn't require a password. And then you can type cat ~/.ssh and this file name, and it will print out your public key that looks a little bit like, here's a public key, for example. In your GitHub account, then you would go to GitHub, your settings, and then SSH and GPG keys, and then new SSH key. And you'll enter that. Maybe you call it like I called it Neuracademy 2024 JHub. And place that there, and then when we get to the point where we need to sort of choose how to authenticate against GitHub, I'll point this out again that we need to choose SSH rather than HTTPS, which is the other way of authenticating. But that's just kind of basic setup that we need to do in order to be able to A, make commits, and B, authenticate against GitHub. Okay. Is someone still doing the SSH thing? Are you all done with the SSH thing? Okay, good. Folks on Zoom? All good on SSH keys and stuff? I see a thumbs up. Okay, I'll just take that as a thumbs up and then just yell at me if that's not. Okay, so I'll go. By the way, you can post questions here, and every once in a while I'll go here and check. I don't actually get notifications. I don't get notifications while I'm sharing my screen. So if you're posting a question, somebody else notices that there's a lingering question here in the room, just kind of shout at me. Or you can unmute yourself on Zoom and just voice your question. Okay. So having done these basic configuration steps, we're ready to go back to the task at hand. So we'll start actually with me doing some Git operations on my machine. You can't do those yet because you don't have the Git repository yet. But very, very soon we will upload this Git repository to GitHub, ask you to clone it onto your machines, and then you will be able to do things on your machine. So the first part will be kind of a refresher of how Git works. on a single machine, you can think of Git as being like a few different levels of operation. The first one, we're sort of tracking our work on our own machine. This is what I'll be showing first here. So before I start adding, okay, so I'm sitting here in this directory that I've created before. It's inside of, I have one in my home directory, I have the source directory, that is where I put the source code. And inside of that, I have a folder called geometry. That's where I've built up a Python library. It's got code, it's got various things. And this is where I initialize my repository. So git init is a command that we need to do only once per repository. And that initializes the Git repository in this folder. I could type git status, and it will tell me that there are all kinds of files in here. And I'm on the main branch. There are no commits yet. And then there's a bunch of untracked files here. And I'll start adding files into my repository and committing them. So git add license, for example, would add the license file into what's called the staging area. So this file used to be here in the untracked files, and now it is in the staging area. And that means that if I make a commit right now, that commit would include only this file. So let's go ahead and do that. Git commit -n adds license. Well, commit messages, it's a good idea to make those informative such that in the future you reading through the logs of this repository will be able to understand what happened. This is pretty straightforward, and they're usually written in the imperative tone. Add license file. Imperative voice, sorry. So add license file. So now we have one commit. If we type git log, we see that one commit because I configured Git to know who I am. There's an author with my name and my email address. This string of numbers and letters is called the Git SHA. It's a sort of cryptographic identifier of this commit and is used in order to refer to this particular state of the repository. I can keep going, git add readme.md. I use the tab here to complete, so that's why that got typed out very quickly. I will often use the tab because I don't want to type things that I don't need to. So that's tab completion. And I will add git add PyProject, git add. And there are a few files here that I don't want to add. It got sort of generated along the way. So I'll sort of, this build file, for example, or build folder got generated when I built the library out of the source. So I can delete that one, or I can put it inside of a file called gitignore. I'll create a gitignore file here. That will help us. I can edit the gitignore to tell it what things I don't want to store. So build the entire build directory I don't want to store. There's Jupyter generates these .ipynb checkpoints folders, and so I'll tell it to ignore that too. I'm using here a text editor called Nano, which is a very straightforward text editor. So when I typed nano.gitignore, it opened this file that I had created, and I can edit it. Nano is nice because at the bottom of the screen, you can see like the commands that you can use. The caret there is the control key. And so control O writes out the file or saves it, and control X exits. So now git status, one thing that's happened is that there's a gitignore file that's now present, but also you'll see it no longer mentions the build folder, and it no longer mentions this .ipynb checkpoints folder. And that's because the gitignore is a place where we tell Git, these are patterns that we want you to just never pay attention to. There is also inside, I believe inside the source, there's also something. Yes, this geometry egg info we're also going to ignore. These are all folders or files that get generated as part of the process of building the Python package. So we're not interested in storing them in our history.
Is Git ignore itself something you want to be pushing?
Git ignore itself is something that I want to store because I want the same kind of ignore rules to apply everywhere that I'm using this.
But it works even before you push it, if it's just in the local directory.
It will be only locally stored, but then if I kind of copy this somewhere else, I want to be able to. So right now it apply the reason that I'm not seeing these other things is there is a file called .git ignore, and Git sees that even if I haven't committed it, but now I'm going to also add that to my commit. Source. I think I can add the entire source directory like that. Git. And then the one thing I'm going to check, yeah, I can add git add tests. So now git status. Oh, I did add this PyCache that I don't want to add as well. So I'm going to git restore staged. And I'm going to, so this, I know to do this command because it says so right here. Many times Git will actually give you useful advice. So if you added stuff into the staging area that you don't want, you can tell it, I don't want this file. Oops. Okay. Restore -- staged. This one, copy, paste. And then I'm going to do that same thing with these other files that I don't want to store. And then these patterns that I've been intending to ignore, I can copy those all into my git ignore file because I just noticed these are things that I also want to ignore, and then lets me ignore them. I think we got everything now. Okay, so I'm writing that out and exiting git status and git add .git ignore because I added it before, but then it was modified. I've added things to it since, so now I'm adding it again. And now in the git status, I have all the things that I think belong to this kind of initial big commit that will include all the contents of this repository.
Just a quick question, when you add git source / geometry, does
Yeah.
that mean that if you ever add another directory to the source directory that is not geometry, will that be added or will only specifically the source geometry?
Good question. Let's try that and see what happens. Git commit initial commit of the Python full Python library. Git status. So now every once in a while I'll kind of check git status. Git status is nothing to commit, working tree clean. That's kind of a good state to be in after when you're finishing your workday. That's a good where you want to be when you're ready to head home. The question is, what if I create another file here, source geometry sphere? Why? Like the geometry of spheres, I guess. Following the same git status. And no, you have to add every file separately. So even if you said git add and you pointed to a directory, what actually got added are files. In fact, Git doesn't know how to track directories at all. It doesn't know anything about directories. If you tell it git add this empty directory over here, it doesn't know what to do with that. So it's actually storing, in order to store empty directories in a repository, you need to do some trick where you add some file in there and you commit that file. In fact, yeah, every file is. So we can continue to add that one as well, because we're already into that, and added empty sphere file for future. Oh, and I should be consistent. Add empty sphere file for future developments. Okay, so if type git log, we'll see kind of the list of commits that we made. The log goes historically from recent to oldest, from most recent to the oldest commit. And this is all nice. We can go and revisit various, check out various states of the repository from previous if we want to see the repository in some previous state. Let's go and make some changes to some of this code just to kind of exercise the Git workflow for ourselves. Let's go and edit this circle.py. Let's see. One thing that is sort of good coding habit in Python is to follow the PEP8 coding standards in Python. It's the language-wide standards for how Python code should be written. And there's just a little bit of rules about how you name variables, functions, how you space things out. And one of the things that PEP8 says is that before the definition of a function, there should be 2 lines of white space. And that's not the case here. So I'm going to add a line of white space here to be compliant with PEP8 in that respect. And so now if I do git status, it tells me, oh, there's some change that's happened. If I type git diff, it will show me what changed. It will say, look, there's a line of white space in this file, in that location. You've added a line of white space. So that's the diff command that tells us what are the differences between the previous state and or the previous commit and the current state. You can also do git diff between various states of the repository using these SHA. So you can do git diff between this SHA and that SHA, things of that sort. Status git add source geometry circle git commit -n add white space for function. We'll come back to this PEP8 thing. I mentioned it only briefly now, but we'll come back to that a little bit later when we see how we really enforce this. Okay, git status, git log. Okay. Let me stop here. What questions do people have so far? Okay, so this is the kind of like the first way that we use Git as a way to track our own work by ourselves. And this is nice already. We get like kind of a full tracking of when did we make what changes, why we made these changes. These commit messages can get more longer and more elaborate than this to describe what we did at various points. Okay, the next thing that we're going to use Git is as a backup system. So we're going to use GitHub itself as a backup system. Well, let me go to, okay, we'll do something here. So in order to use GitHub as a backup system, we would like to create a repository on GitHub that will store the repository that is currently stored in my pod. So I'll do that. Oops. I'll do that in the Neuroacademy 2024 GitHub organization. We already have a few repositories here. Later on, maybe you'll be interested in contributing to those in some ways, but I'll start a new repository here and I'll call it geometry. Okay. And in creating these repositories, you can decide whether you want them to be public or private. I think that if you have an educational account on GitHub, then you can get as many, I believe, as many private repositories as you'd like free of cost. I think if you're not, if you don't have an educational account, at some point you need to pay for these private repositories. At any rate, we can make this public, I guess. And I'm not going to add any of the things. When you initialize a repository, you have the option of adding into that repository things like a gitignore file or a README file or a license. And I'm not going to do that because we've already added those to the repository on our local in our pod on the hub. I'm going to create an empty repository. So for now, it's empty. This is what an empty repository looks like. And it has some instructions down there for quick setup. Now, as I mentioned before, it's important for us to have, when you later clone this, there are two options to use authentication with SSH or authentication with HTTPS, and we'll always want this SSH, and that changes the form of this string that we will use in order to clone the repository. So in this case, we don't want to create a new repository on our command line because we already have one. So all we want to do here is push an existing repository from the command line into GitHub. So we're going to follow these instructions here. The first thing that we do is to add so we're going to use Git has, as you've already seen here, Git has commands that have subcommands. The git remote command is all about managing the relationship between the repository that is stored on this machine and remote versions of this repository. Remotes can be other computers, it can be systems like GitHub. So in this case, we're using the add subcommand of the remote subcommand to add this as a remote called origin. So we're going to call this origin, and we're going to give it this URL, this SSH URL to add origin. Now, it hasn't done much yet, except now if you type git remote -v, it'll tell you I have this remote, this is where I'm fetching this remote, this is where I'm pushing this remote. You can configure these remotes to be really fancy, such that you're getting the repository, you're fetching from one place and you're pushing to another place. But in this case, and in every case that I've seen in my life, those are identical. But anyway, it's good to verify that this is pointing to where you intended to point it. And then finally, well, git branch -m main, which I don't think we need to do because I believe we've already done that. Yeah, the branch is already called main. This command here, git branch -m main, would change the name of this branch to main in case it was named master. This is a bit of a historical kind of weirdness that when Git was originally implemented, the default branch was called master, and then people pointed out that for a variety of historical reasons may not be a great name for anything in computing, and instead people have sort of converged on the idea of calling these per default main. The software hasn't quite caught up yet, but we all change our default branches to be called main anyway. So that's what we have here already, so we don't need to do that. And then the final command here is git push -u origin main. So git push is the command that takes a repository locally stored and pushes it to, or copies the contents of this into a remote. In this case, we're telling it, put it in the remote origin and do this into the branch called main. -u tells Git that every time that I will type git push, that's shorthand for this command. So this makes subsequent calls to this command more rapid. I typically type the whole thing out anyway. So I would typically type this anyway. So I'm going to take out that U. It makes it easier in subsequent uses, but I typically want to know what I'm pushing and where. So I want to know what I'm doing exactly. So I typically type the whole thing out. Git push origin main, or git pull origin this branch, or git push some other remote, some other branch, right? So I want to write those out so I can think about it. And it gives me a little speed bump so that I don't do something the wrong thing. So I typically just take out that U that they recommend. Here they say, I put U, and that way you don't have to type the entire thing. You'll just have to type git push from now on. But I'm ignoring them and going with my way of doing things. Okay, so now having pushed this here, you might have seen on the command line that Git did a bunch of things. It did compressed things, enumerated things, did things, and then it tells us there is a new branch here called main, and that branch contains the contents of the repository, and that went up here, and here it is. So this now contains our source folder with the code, and it contains the tests folder with the test and a bunch of machinery. I noticed, by the way, I never put a license in here, even though I mentioned licenses before. So let's to fix that. Let's do one more round. Here it is, the MIT license. So I'm going to copy this text, and we'll do one more round of committing and pushing here. I will open, where is it, source, geometry license. I'll open this license file. I'll put 24. And this is the MIT license. So I'm saving that. And now if I do git status, it will tell me there's a file that was modified. If I do git diff, now it has a whole bunch of stuff, and that's because I've added a lot of things in here. And then I can do git add license, git commit -n, add license contents, git push origin main. And that then updates this with the text of the license. It actually automatically notices that GitHub is trained to notice that this is the MIT license. And in fact, when we go to this, it'll, I think at some point, yeah, here, it has like a little thing. It tells us. So you can go to repositories if you're interested. What license this project use? You can go and see. Sometimes they will GitHub will recognize these standard licenses. So that's good. Okay. So we have this repository up here, and I can continue to do what I just did, these cycles of changing the code. So making changes to the code, git add the file in which I made changes, the files, git commit -m, a message, git push, origin main, and that would continue to update. So we've gone from the first level where I'm tracking the log, or kind of like the development life of this project, to have a backup as well. So I have backup on GitHub. In this case, I've also gone ahead and done the third thing, which is sharing it with the world, because this repository is also designated as public, so anyone can see it. So now anyone else who's interested can download the code, can do whatever they want with that. So that's all very nice and useful already. But really, the big strength of Git and GitHub start to really shine when we start collaborating with other people. So that's what we're going to start doing here next. So the first thing I'd like to do is then go to this repository. Let me send it to you over Slack, and make a clone of this repository. So the way to do that is here in this code tab, you will select, if it's selected to HTTPS, you will select SSH, and that's important. You can click on this button here to copy that URL, and then you'll go to your to the hub, and you can, I would recommend making a directory called source here, or something else, not storing it in the top level, but instead storing it somewhere inside of a directory. And then the thing that you'll do, you'll go into that directory, and then you'll type git clone, and that clone URL. I won't execute that here because I already have this repository here, but this is the command that you would execute. And again, this is a command that you execute only once in order to clone this repository into your machine. So then everything that is in this repository should show up in your file system on your side of your side of things.
So I'd probably have to delete the geometry directory from previous session.
Or put this somewhere distinct from that one. Yes, if you worked on this in the previous, then yeah, put it somewhere else, not where you previously worked on it. Yeah, that would confuse us all. Okay, and I'll pause here. What questions do people have about any of the things that I showed until now? Any questions in Zoom? I'll kind of open this up.
Oh, there's something on Slack.
Oh, there's something on Slack. Let me see. Is there a downside to using git add dot on the project root directory as long as there's a properly specified git ignore? Also, can you share some best practice around the scope of commits, i.e. how often to make them when working on a project? Okay, this is a good question. I prefer not to use git add dot because, or at least if you do that, use git status as I did, right? At some point there, I did do a git add, here's the directory added. But I did go, if you remember, I did go there and did a git status and cleaned that up. The reason not to do that is you'll end up with things like this in your Git repository. And these kinds of things are tricky the reason not to include these PYC, these are compiled, byte compiled Python files, and they're tricky to version. You don't even want to version them really. You don't want to include them. So whenever you're doing git add dot, you're kind of risking adding things that you didn't intend. So in a sense, yes, if your git ignore is already properly set up and you're willing, if you kind of like do this every time, then you'll be okay. But as I try to avoid that, like having that to kind of like do the thing that you automatically do, because inevitably you'll get into situations where you're committing things you didn't want to commit. So that's about that. And then best practices around scope of commit. That's a really good question. I think of commits as being like a conceptually coherent thing. So if there's changes to multiple files that all belong together into the same conceptual, I fit together into an idea. I did X. So if this implements X or Y, then it's good to include them. When in doubt, I actually tend to prefer smaller commits rather than bigger commits. It's easier to deal with. You're more likely to regret adding things, putting things together in the same commit than regretting putting them in separate commits for a variety of reasons. You can later on, you can edit the git commit tree in various ways. And if you included multiple things in the same commit, that makes it harder for you to edit separately those things. So when in doubt, small atomic commits are the way to go. And then you have multiple commits and that's fine.
Keep getting, cannot read.
Sorry, can you repeat that?
I keep getting like cannot read from your repository when you try to clone it.
Oh, are others seeing that as well? Oh, this could be, are you in our GitHub org? I guess so, right? You're signed into this. Did you set up the SSH key? Yeah, this might be something about SSH key setting.
Set up this HP and I thought I put in the password. Maybe something.
It sounds like an SSH key thing. So maybe let's sort that out. Yeah, maybe try repeating the process with the SSH key. That might help. Okay, and others now you have the repository on your machines. Okay, great. Okay, so now we're ready to collaborate, right? Because I have a copy, you have a copy, we can all collaborate together. The first level of collaboration that we can instantiate is one in which we all share this repository and we're all pushing and pulling into the same place, into this main branch. So we'll go into branches in a minute here, but for now, let's do a simple thing where we all collaborate in the same place and we'll see how things can go wrong in various ways. So what I'll do is, if you're working with collaborators and they're trusted collaborators that you are willing to have push into your repository, make changes to your repository, then a simple way to do that is to give them permissions to write into this repository. And you can do that by changing the settings here into the collaborators and teams, add people, and then let's see, who wants to give me their GitHub username? If you want to collaborate with me, type in your GitHub username. I'll take the third one that shows up. The first one, I'll take the first one. I'll take whatever you give me. Oh, there we go. Thank you, Jonathan. Okay, we'll add others later, but let me add Jonathan for now. And you can give very granular sets of permissions here. So I can allow Jonathan to be an admin on this repository, which would let him then destroy this repository, manage there's secrets you'll see later and so on. But for now, let's just let this person write into this repository. And so now what I'm going to ask you to do is to make a change in some place in the repository, in some file. Add that change, commit it, and push it. And then we'll see what happens. Oh, in the meanwhile, I'll add the others because that's only fair. We'll make a big mess here. Okay, and then let me know. For now, the others stand by for now. Don't do anything so we don't get into a mess here. I'll show you how we can get into a mess so we can get ourselves out of the mess as well. But for now, let's just wait for Jonathan to make his change. All right, let's do that. Okay, so there's some text added to the README. Okay, yeah, I did not add text to the README before, so now there is text to the README, and that's great. So I can now we can sync up by having me then using the git pull origin main command in order to sync up my code with the code that is now in this remote called origin, which is this GitHub repo. And now git log here shows, you see that commit is kind of at the top. And I can make more changes and push them, and Jonathan can pull and push and pull and push and pull and push and pull. And that works just fine. That's a pretty decent mode of collaboration. But there are two reasons that doesn't necessarily always work for us. There's kind of like two stumbling blocks. One, which we'll see next, is the potential for conflicts, even when you're working with collaborators. And the other is it doesn't scale very well. I can't, for example, if somebody who doesn't know me wants to contribute here, or somebody I don't know wants to contribute, they'd be tricky. They'd have to ask me to become collaborators. I'd have to trust them. And so there's a really good pattern to work in GitHub that allows me to collaborate with people I don't even know, and I don't need to trust because they will tell me what the changes are that they propose before we apply those changes. That's going to be the next thing that we'll show. But first, let's see about the potential for conflict. So what we're going to do is, Jonathan, you and I are both going to make changes to that same line that you added. So I'm going to open the README file and I'm going to write one thing in there. This is a README that I want to change like this. And then you, in the same place, make changes that are different.
Around with preparing for
what happens.
Sunday to have
So
all the contracts translated.
This usually works all fine up to the point where, and Git usually knows how to resolve. If I make some changes somewhere and my collaborator makes a change somewhere else in the repository, Git knows how to merge those things together into clean history. It's only in the case where we both make changes to the exact same line in the code simultaneously that things can go wrong. So I'll do that here on my end. I'll do git add readme and the git commit -m make a change to readme text.
I'm patient. I'm done on gratitude.
And then,
All those things, but
did you also make changes?
Yeah, I haven't pushed yet. Should I push?
Did you push already?
I have not.
Oh, push it also.
Okay.
You'll push on your end. So we'll make it this so that I was working on my computer. At the same time, Jonathan was working on his computer and he made some changes and he pushed those to GitHub before I had time to push mine. So now let's see what the README says now. It says it stay like this. Okay, so we have different versions of this. This is good. So now if I try to push origin main, I've been working on my end and I'm just minding my own business over here, making changes to the README, and I try to push, GitHub will tell me that it can't push, and it sort of my push is rejected, and that's because the history on the remote is different from the local history, and it actually helpfully says, hint, try git pull before pushing again. Now, if we had made changes to different parts of the repository, I was working on one file, I was working on a different file, I could do git pull and things would be just fine.
There should have been one this morning, but his
Git
camo said it
pull
was too hard for
origin
him.
main. Sorry, I forgot to type that. Oh, and it's okay. Diverging branches.
Trying to mask him to know
Branches
when he's
can
ready.
you fast forwarded. You need to
Doesn't
either
feel
git
like he's doing
merge
too good.
dash dash no ff. I thought I set that strategy already, but let's just do this. Let's do what I wanted to do. Yes, okay, good. So now what happened was we were working separately, and then eventually I get this message and I managed to pull, and I say only I set the strategy to be such that it would only merge if it could merge without conflict, but there is a conflict. And so now what Git does helpfully for us, oops, I should close this one, is that introduces what we call conflict markers. These markers inside the file tell us that this is the place where, so first of all, Git in all caps tells us there is a conflict. And helpfully, it also tells us in the file where the conflict is, what lines. And if this was a multi-line conflict, then there would be sort of additional lines here and additional lines here and so on. So this is not it doesn't have to be a single line, but in this case, it is just a single line. Now, the problem here is not necessarily a technical problem. This is the technical solution. The problem is a sort of a social problem, right? We didn't coordinate. I wanted to do one thing, he wanted to do something else. And at this point, when we have this conflict, maybe we need to talk to each other and sort of agree what this should be like, or maybe I will enforce my will here and change this to what I wanted. So in order to deal with these merge conflicts, and you'll see those sometimes, even in other workflows that we'll talk about in just a minute here, sometimes you need to go in and kind of edit this and apply the changes you're actually interested in. So let's say that this is, we come to some agreement that this is the way that the file should look. And now I can go and I can git add readme and git commit -n resolve. I think that's how I do this. And then git push origin main. And now everything is fine again, as in there's the conflict resolved file exists here. Something that I haven't shown you before, but is worth kind of underscoring now, is that all of the commits in the history are stored here in this GitHub repository. So this also does do the function of tracking the changes along the way. And in this case, both my change and Jonathan's change to this file are stored. So we can always come back to this change that I kind of overruled with my conflict resolution. You can always see, so it's not a lossy operation in the sense that all the history of both of these kinds of sets of changes are still stored here. We can always come back to that if we want. Okay, so this is one mode of collaboration. This is kind of the failure, one of the failures of this mode of collaboration. We're all pushing to the same repository, pushing and pulling back and forth. And so now you all as potential collaborators should actually issue a git pull origin main in order to bring your repositories up to date to where we are here now, because the recent changes are not on. When you cloned it, those changes didn't exist. So one of the things about Git is that you need to actively change the repository, the state of the repository in your machine. So you need to do git pull origin main in order to sort of bring everything up to date on your machines. So this is, like I said, this is one mode of collaboration, and it's not uncommon to use this. In some senses, it's easier. But like I said, it leads to these kind of merge conflicts, and it's not scalable to like collaborate more massively. And so the next mode of collaboration that we'll look at is a mode of collaboration where each collaborator has a copy of the repository in their GitHub account. How do we do that? Well, in this geometry that we all designated as the origin, there's a button, a fork button. This fork button, what it does, if you click on it, is, well, it asks where you want to fork that to. I have many options. You might have some other options. I already have a repository called geometry because I've done this before. So I'm just going to call this geometry NH 2024 on my account, but you don't need to change the name. I need to change it because I have another one called geometry. But in your case, you can store it as geometry, and that's actually simplified things a little bit. If you hit create fork here, it then does some things, and then there is, in fact, on your account, so now this is my username, aerochem, there is a repository called geometry underscore NH 2024. In your case, it might be called geometry, simply the same as here. And that repository is marked as having been forked from the Neurocademy 2024, this kind of central location where we're all forking from. So a fork in open source software development, a fork is like a bit of a jargon that talks about taking somebody's code and changing it in a way that's different than they changed it. But here, these forks are more friendly than that. This is not an adversarial fork. This is a collaborative fork. So you're creating a fork. You're creating a version of the repository on which you can do your own work, and then you can maybe propose changes to the work that's being done in the central location. So we'll all be synchronized through these various forks that you have. And I'll show you how that works. So the first thing that we need to do is we need to tell our repository, our local repository, the one that we've been working, that there is another remote to consider. In my case, it's this remote. So I'll copy this URL, again, the SSH URL, not the HTTPS URL. And I will, by the way, that might have been also an issue for you if you use the HTTPS URL instead of. You fixed that, okay, good, thanks. Great. So git remote add, and I'll call this aerochem, like my username, and I'll add this as another remote. So now if I do git remote -v, I have two remotes. I have one that's the origin, that's the Neuroacademy one, and then I have another one called aerochem that has this other location. The beauty of this, well, part of the beauty of this, you'll see the full beauty in just a few minutes here. But part of the beauty of this is that I own this repository, or in your case, you own your fork, and you can do whatever you want here. You can push, because it's yours, you don't need my permission. You don't need me to add you to the Neuroacademy version of this repository, a fork of this repository, in order to make commits into this repository. You can do whatever you want with this. Now, typically, we'll do this because we want to collaborate together in some way. And so we'll need to think carefully about how we make changes to our own forks in such a way that we can sync up with the Neuroacademy version. And a thoughtful way of doing that is by using the branch mechanism in Git. So the branching mechanism in Git, until now we saw, if you type git status here, you'll see that we are on a branch called main, and that is the default branch for Git. But we can create new branches and make changes to these branches in a way that doesn't affect the code that is on main. It's a little bit like the forking idea, but it's very kind of like locally in your own sort of workspace. You're creating different versions of the code under different names. So for example, let me create a branch, git branch, another test. I'll create another test. And that by itself created the branch here, but we still haven't switched into that branch. So in order to switch into that branch, I type git check out another test. And now if I type git branch, you'll see that another test is green. It's got this asterisk. That means that we are currently sitting in the another test branch. So we've created a branch, we've switched over to that branch, and now the changes that we will make to the file system apply only to this another test branch and not to the main branch. Let me show you how that works. For example, in the tests, I can in test circle, maybe I'll test def test calculate circ, and I will add another test here, circ 1. I think this should be equal to 2 pi. I think that's right. but I won't even check this. I'm just gonna add this. Git diff tells me that there's some change here. Doesn't like the fact that I have white space at the end here, and I don't like it either. There we go. Okay, so I've added some code here, and it tells me that I've deleted some code, but that's because I've introduced a new line at the end of that code. That's the reason it looks like it's deleted. This line changed only in the sense that there's a new line now. So, okay, git add tests test circle, git commit -n adds a test or add a test of calculate circumference. Now, just kind of demonstrate what the branching mechanism does for us. If I type git checkout main, I switch over to the main branch, and I go and visit, let me close everything here so I don't get in trouble. I go and visit the test circle file. It doesn't have this function. Again, if I git checkout another test branch and sorry. I need to always remember to close these things. There it is. Okay, it's back. Now let me close this just to demonstrate this again. Git checkout main. Gone. Git checkout another test. It's back. Okay. So the principle is understood. There's changes on one branch that are not on another branch. These are changes to the file system. Every time that I type the command git checkout with the name of a branch, Git will switch the contents of the file system. One way to think about that I like is think of this checkout command that you can do a lot of things with, not only these things, but is like a library. I'm going to a library. The Git repository is a library, and I'm checking out some book from it. And so I can check out branches, I can check out individual commits, I can check out files in different, I can check out tags. There's a variety of things that I can check out. And here I'm checking out a branch. So git checkout is kind of this all-purpose, I'm going to the library and getting this thing. And it changes the file system, literally the bytes on the file system. So that's the branching. How do I use that in the context of a collaboration? Well, I can push this branch, another test, into my remote. And so now I have on my remote, well, I have this cool message up here that we'll come to in just a second, but just to point out that I have view all branches. I have different branches here. I have this active branch, another test. If I go to that, it will show me the state of this file that includes this additional test that I added. And if I go to my main branch, it doesn't have that. So I have all these branches living simultaneously in my repository. Notice that I pushed them to my remote, my own sort of fork of the repository. So if I go to the main repository here, the root node, this one doesn't have this another test branch. It's only on my fork that this another test branch exists. But here's where the collaborative pattern comes in. So if I've created a branch and I've pushed that branch to my fork, I can now propose to incorporate those changes into the main branch on the upstream, the root node of the forking network. And that I do by clicking on this compare and pull request button here. I can also do that by going to, there is a tab here called pull requests. I can issue a new pull request and I can say compare across forks, and then I can choose my fork here and I can compare this new branch here. I'm doing this in detail because that's kind of the most detailed way of doing this. And then it'll tell me this is the proposed change that you're offering. So it'll kind of open this dialog for me. And if I hit this green button that says create pull request, then it'll open this up and I can add a little bit more of a description here of what I'm trying to do. This is a good idea. And that's because what this pull request interface provides is a way for me to communicate with all the collaborators on this project and say, here's what I'm suggesting, here's why I'm suggesting this, here's some links that refer to maybe issues that we've seen in the past, or maybe literature about this, and if I'm proposing some new method, I can write a whole message here. And that message then will be received, as you'll see in just a minute, as an email by everyone who's a collaborator on this. I think all of you who have forks of this will now get an email in just a second. I think it's a good idea to test this function. So create this pull request, and now it's checking for the availability to merge this. And I don't know, did you all get an email about this? Who all got an email? I'm just curious, actually, if only the people who were designated as collaborators on this repository. Everyone. Yeah. No, nobody. At least you should have gotten. No,
It might just not be updated.
it might take a little while. At any rate, I think you should all be able to go here to this page that designates this pull request. Oh, so I'll put it up here and write some comments on this pull request. Not only can you comment down here and say things like, that's a great idea, or I think that's silly, or you can actually go to this tab that includes the files changed and comment line by line. You can say, what happened here? And then if you click on start a review, it'll store that comment until you're done making comments. Maybe you'll say here, what about a new line at the end of the file? And then it'll store that too. So it stores all these. You see they're marked as pending until you finish your review, and then you can say, I want to comment, I want to approve, I want to request changes, whatever is kind of the category that fits under. I can say, I can't actually approve my own, so this is blacked out because it's my own pull request. I can't approve that, but you can possibly approve that if you feel like it's good. And you can leave a general comment here, something like, this is nice work. And then when you submit this review, the messages that got stored all kind of get pushed into this pull request interface, into this one page. So if we all go to the repository, to the tab designated as pull requests, and then click on this one pull request, we get sort of the comments that I made and maybe comments that other people made along in one long kind of discussion. And when we're all very happy about all this, someone who has the right permissions on this repository can hit the merge pull request button. And what this will do is it will merge this branch into the main branch on this repository. So I'll demonstrate that, and then we'll make more pull requests. Let's say that we're happy with this. We do this and we confirm the merge, and that means that now if we go to geometry and we go to the main branch, we will see that on the main branch, on the Neurocademy/geometry, this test is now implemented. And so now, to close the loop, what I need to do is I need to update my main branch in my machine, and also my main branch on my fork. So I will go and check out the main branch. I will do git pull origin main, and that will now update that with both my commit from my other branch and also with this merge commit from GitHub. So this is like in my log, this tells me this is where that particular branch got sort of merged into the history of the repository. And then I can complete the cycle by doing git push arrowchem main. And that then updates not only the Neuroacademy fork, but also my fork with my fork. So now on my fork of the repository in the main branch, this test is also implemented. And that closes the loop. So now everything's complete. That's a one step in changing the repository. So that's, and just to repeat kind of the steps here all throughout, if you want to propose a change to this repository, you need to make a fork of the repository, designate that fork as a remote on your local copy, make a branch on the local copy, make some changes, make commits, add all those changes, make commits, push those commits to that branch on your fork, and then make a pull request from that branch on your fork to the main fork on the main repository, the NeuroAcademy 2024 repository. Have a conversation with your collaborators about those changes until someone is, satisfied enough, or the project is satisfied with those changes, and then those get merged, and then we all update our main branch, we all kind of push our main branches to our forks, and we keep going. This pull request mechanism is very neat, and that's because it allows us to have a whole conversation about the code, including line by line comments on the code, and also the history of this change is stored here now. So if we wonder, why did we add that test? Why is this test here? You can always go back and see this discussion with all of its history and all the changes that happened along the way to kind of explain that. I should say, and I didn't demonstrate that here, but if you're working on a branch and you made a pull request off that branch and you're making subsequent commits on the same branch, all of those commits will get pushed into the same pull request. So if somebody else proposes some changes as part of the code review, then you can implement those changes into the same branch and just keep pushing into the same pull request. And this is, I should say, Russ mentioned code review. This is an excellent platform for code review because it allows people to go in and kind of comment line by line on what you've done. Okay, now it's your turn. So what I'd like you to do is pull the most kind of recent version of the main branch, git pull origin main, into your repository, git branch some name of the branch that you'd like to do, make changes. Git check out that branch, make changes, add, commit, push, and make a pull request. There's a lot of steps. I'll write all that into Slack also, okay? So that you have like the full story. But if you're ready, then. This one, in case you haven't done this yet. By the way, if it puts stuff in angle brackets, that's sort of fill your own thing there. Because a branch name can be whatever you decide to call it. The username is your GitHub username. If you hear people say PR instead of pull request, same thing. And that's acronym. Okay, and then, type to Slack or raise your hand or shout out on Zoom if you get stuck on any of these things or you have a question on one of these things, just let me know. Differences between cloning and forking yeah, so what's the difference between cloning and forking? Clone is the operation via which a repository that is in GitHub somewhere becomes a repository on your machine. Forking is an operation strictly on GitHub where we took this repo here, this Neuroacademy repo, and we created a fork. Now I can actually see all your, let's see. Oh, I can see somewhere here, I think the list of all your forks. So forking is a GitHub thing, strictly a GitHub thing. It's not actually a Git term at all. We should say Git and GitHub are closely integrated, but they're two separate things. GitHub is this website that does all these things. Git is the application that runs the program that runs on your computer. So Git clone is an operation that lets Git make a copy of something that's somewhere else, and fork is something that happens in GitHub. I hope that answered. Sorry, there's Git even worse than many of the other things that we teach in Neuroacademy. It has so much jargon associated with it and takes a little while. I should also say I've been using Git for a while now in my life for everything, and it didn't come to me in one day. It took, I'd say, between 6 months and a year to get used to all this stuff. It's one of the things, among all the things that we teach here and among all the technical things that I deal with in my life, it's probably one of the most complicated, least intuitive. So if you're having a hard time with this, that's not because of you. Git is really not very intuitive, but very useful once you get used to it, sort of like learning an exotic language. Well, exotic. A strange one at anyway, one with very strange logic. I think I could say that as somebody who speaks languages that have strange logic.
I don't know if there's any other questions,
Yeah.
but so like similar to this, but I guess when would you use, I mean, like if you didn't have access to a repository, like you didn't have edit access, you would fork it.
Yes. So
Then you would like just work on it, whatever.
yeah. So this
Other
is
than that, why would you use that?
the forking mechanism because of the pull request mechanism that is so nice in order to collaborate. Otherwise, if you're working in the mode that we worked before, there's one repository and we're all pushing and pulling, there's the potential for conflict. But you could solve that actually by making branches, just by making branches and making pull requests into that. Actually, yeah, to answer your question, you're right. Yeah, you could make branches on this one place and without the forking. The forking really allows you then to scale to people that I don't even need to designate people as collaborators. Everyone can fork and contribute. So, and using that mechanism is, it's useful to show that mechanism because maybe one day, maybe next week, you'll see some project that you want to contribute to. And this gives you like the ability to contribute to all these other projects. So many of the projects that we, this kind of code that we'll show here from, I don't know, machine learning libraries or, Python processing, neuroimaging processing, all those use these kind of mechanisms in order to introduce changes. Yeah. Yes.
In terms of procedure, we cloned the main repo and then made a fork and added it as a remote.
Yeah.
If I wanted to have my fork like from the get-go, would I first fork it and then just clone that fork, or would I still do it the way we did it now?
Yeah, you do actually more typically, and I should. So now we have this situation where if you type git remote -v, you'll see there's something called origin here, and there's something called arrowchem here. It's actually more typical to go the way that you described. You find some project you're interested in, you make a fork of it, you clone your fork, and then you make another. So I'll show you what I think this ultimate state that we want are. This will be a little confusing, but as remote rename origin upstream, remote arrowchem origin. Oh, git remote rename. So this command, it's not as, you can kind of understand what I did here. I took the AROChem, I called it origin, I took the origin, I called it upstream. So kind of by convention, the way I usually set up things is that origin that I actually cloned from is my fork. And upstream is the upstream kind of main node. It's kind of like in this case, the Neuro Academy 2024 version of the repository is what I call upstream. So in the end, I usually end up with something called origin, which is mine, has my username on it, and another thing called upstream that is sort of the one that everybody is kind of pushing and pulling to, or kind of like forking, the one that we're all forking from. And ultimately, all these operations that I did now, the ultimate result is all the same. So it ends up not mattering in what order you did things in this case.
Could you say again what leads to a pull request? Like what do you need to be pushing into the, do you push into the origin or do you push the?
You push into what now is the origin, which is your fork. You push into your fork and you make the pull request from your fork to the, what I call here, upstream, which is the central node of the
So
network.
does any changes you put, but it has to be on the main branch? Is that what
Usually we do pull requests, except in some weird use cases.
you push wouldn't be a pull request? What makes it, how do you make it a?
You have to go into here and click like create pull request in order
Okay.
for the pull request to get created. So here's, for example, here's the pull request. You can kind of look at it. There's some change here. I'll point out one more neat thing about the pull request. One more thing that we can do is suggest changes to the pull request. This is very, very useful if you're editing large files and many, many changes. And instead of saying, could you do this instead of that, you could say, here, suggesting, for example, here, I'm going to suggest less exclamation marks. Sorry, Teresa. So I start the review and then I say, good change proposed, but maybe just a little less enthusiasm. Sorry. Less enthusiasm. I don't know. I'm just saying, sorry, so that gets incorporated as a suggestion that then Teresa can go in and say, oh, this seems like a good idea, and I could click on this commit suggestion, or she could click on this commit suggestion. Let me do it here so you see it. And then that commit gets incorporated into the history of that pull request. So now the complete change is both the change that she proposed, the second line, but also the change that I suggested, the deletion of those two exclamation marks. And you can see the conversation has like there's my comment here, and there's this outdated set of code that you can go and look at if you'd like to. And so there's the full history, and there's actually two commits, one made by Teresa here, and another one made by me. Even though I never downloaded this code to this machine, I never edited it on a machine, I only edited it on GitHub, that gets incorporated into this. And I can say, okay, now I'm ready and merge that here. So that gets merged. Let's look at another one. This one's going to be in trouble, right? Because here in this case, the change was to the same file in the same location. So remember the conflict situation? Now the conflict doesn't have to happen on anyone's machine in particular. In fact, now it's a bit of a trouble. Who's this? Is someone in this room? No, someone on Zoom. Morgan, this is your change, right? So the problem with this now for you is that you've made changes. In the meanwhile, I've merged this other pull request that incorporated these other changes. There is in fact a way to resolve the conflicts on GitHub. I can go here and edit, just like I edited before on my machine. But more typically, maybe what we do is we would ask Morgan to go and pull the current state of the main branch, merge that main branch into her change branch, and resolve everything there until this has no conflict. There's another thing that could happen. Conflicts can still happen here in this setting, but they don't get resolved on the main branch anymore. They get resolved in individual kind of topic branches. Or we can resolve them right here. I can go and say, like maybe I'll incorporate all these changes. So I'm editing this in this text editor that's GitHub provided. And I say mark is resolved, commit merge. So this makes a commit again on GitHub, similar to my suggestion before. And so now the full change again is everything, right? It includes what is currently on main because I just made I merged Teresa's pull request. And so now there's this additional thing. And I can then go and again, there's two commits here. One is my merge of the branch main into this thing by resolving the conflict. And then this change, and I can go ahead and merge that as well. And so now if we look at the history of the full project, we get everything here. We have first another test that I did, and then Teresa's change in her pull request, Morgan's change in her pull request, me updating this on Teresa's pull request, the merge, another merge in order to resolve the conflict, another merge in order to merge the pull request. So all these things get stored. Yes.
I had a question just about like incorporating this in workflow. I do a lot of collaborative projects where like we have a shared like server, so it'll be like a project and then data folder, folder, and then sometimes the code is a Git repo.
Yeah.
It seems like this is all really designed for everyone to like have their own like copy of the repo separately.
Yeah.
Should we just stop doing like how do we? I don't know. Like, would you have people have different?
So this is, I will say, this is the most, this is the most complicated workflow. This with the individual forks and the pull requests and everything. And I figured I'd sort of show like and this is what I use for a lot of collaborative projects like that. And once you get your head around it, it becomes easy. But for some particular cases, it might make sense when you're working with your like 3 collaborators, you're all sitting in the same room. It might not make sense to be like sending each other emails to like make changes. So it depends a little bit on the structure of the collaboration. Ultimately, if you just kind of incorporate this workflow into all of your work, in the long run, it makes it easier in some sense. Like my collaborators, I usually push them into this pattern eventually. And then, y'all will next week hopefully create GitHub repositories, collaborate with others, with folks in your room and so on. And you'll have a chance to kind of practice doing this and seeing like what works. Once you have a fork, it doesn't like force you to always use this, right? If you're collaborating on a repo, I could always push to the upstream, right? And do kind of the easier version of this that doesn't have the forks. So you can kind of switch back and forth and kind of whatever works approach. Does that answer your?
Yeah, definitely. Thanks. I guess the other question that I have is like, how do you manage like do you have any like suggestions for managing like the people side of this as well? Like, because I feel like, so what happened in that case is I have like the graveyard of like uncommitted files, like.
Right.
Just, I mean, is it like, do you work it into kind of like project meetings and like, how do you kind of keep this like tidy and flowing when most of the people that you work with are like not software engineers?
I would say create a lot of repos is one way to deal with the people side, right? Like have shared code, like this is library code, right? This is the code that we're all using. Keep that as neat and tidy as possible in one repo. And then if you're working with another student and they have their own project that kind of uses this, that has like a pile of notebooks, for example, have a repo that is a pile of notebooks. I have that. I have like a ton of pile of notebooks repos that use library code. So I try to separate things. And this is kind of here I'm thinking, oh, this is a software library. Everybody uses it. Everybody collaborates on it. Let's try to keep that as neat as possible and kind of up to kind of some high standard. And then in another repo, keep track of like my individual kind of notebooks and use the pattern. We started off with this, like I'm keeping track of the work that I did and maybe I make a backup. That's a perfectly valid use of Git and GitHub. Doesn't use all of the features, but for some project, like my own like notebooks that I'm doing some data analysis, totally appropriate. Some projects there's just me by myself with my GitHub repo and I just push to main, just do things and push to main. Okay, yeah, what other questions?
Just a very technical question. When you updated Teresa's pull request, Because it's called a commit, would that just change the pull request or also actually Teresa's forked branch?
I believe that when I made that change, right, there was this suggestion box and I did the suggestion, I committed that. Teresa then, the appropriate workflow there would have been for Teresa to pull her own branch into her machine because that commit didn't magically somehow appear on her machine. So she needs to pull from her own branch into her branch in order for those changes to get incorporated. So once she sees the email that I made a change and I committed it, she needs to go and pull before she makes any other changes so that we don't get into a conflicted situation in that pull request. Yeah.
So like you're able to commit to her branch.
Yeah.
Technically without her
Permission.
allowing you to do.
Yeah, it's a weird situation. It's a very weird situation where I think depends a little bit on the permissions on the core repository. I'm actually allowed to commit into somebody else's fork without their permission. I don't even need to be a collaborator on that. And that's because that was forked from repository that I have permissions on. It's a weird permission situation, but yes, you
So
identified correctly.
if I wanted to use someone's code, but like actually change it, not in terms of like collaborating and changing something with that, but just because I need a personalized special change to it, I would then rather commit than forget.
You can do this, get remote add. I'm trying to find Teresa's fork here. That will take me a minute.
Geometry underscore.
Yeah, but your username, oh, Teresa Chen. Here we go. So I can go to this. That doesn't give me what I want. Sorry. Through this. So I can do this. I can add as many remotes as I want. This is the HTTPS link, but imagine it was the Git link, Git remote, add Teresa. All right, so now I have 3 remotes, and this is actually quite common for me in collaborations that include multiple people, where I can now, if there's a branch on somebody else's fork that I want to pull down and just test out on my machine, I can do like git. I can fetch down that branch from that fork, and so I can add as many remotes as I'd like here. And in some cases, I have like dozens of them for multiple different users. And so does that answer your question?
Partly, actually, the other one was if I have a toolbox that I want to use, but I want to make some custom changes to it for whatever reason.
Yeah.
That I don't intend to like push
upstream.
like special, like I
Yeah.
think there's a benefit to that, and maybe even destroy something, but I want to have this custom change in that scenario.
You want to make a real fork of that project.
Would I then rather clone it?
Yeah, it's a tricky situation because you'd run into all kinds of situations where you want to update things with the thing. So it's a complicated thing to manage, but yeah, typically what I do is make a branch on my fork of that and then try to keep that branch up to date with other things. But it's often a struggle, I'd say, to keep up. Yeah, let's do 2 more questions and so here, go ahead.
So I know like there's a lot of Google Colab. Google Colab to create a lot of like the beginning code.
Yeah.
And then we're using Git to just really be like a code holder.
Yeah.
So do you see long-term issues with that setup? I mean, I know that there.
Yeah, I mean, when Google closes Colab, you're all in trouble, right?
Fair.
But sorry, that was snarky, but I mean, there's some issues with Colab itself. The format is not fully compatible with the Jupyter format, but as a principle, it's not too bad, right? You're starting off doing this, and then you kind of download this thing and you start your code from there. And I don't see actually a huge problem with that. You download that, you create your Git repo, and then off you go from there, and that should be fine. I mean, generally, Git and GitHub don't work very well with things like Google Drive and like Dropbox and stuff like that. So you might end up in situations like all these things trying to fight each other. But I guess different tools for different use cases also, right? It sounds like Colab has like a very specific kind of purpose in your workflow, and that makes a lot of sense. And then this can fit for other things as well. So maybe that's.
Maybe like a follow-up question would be, do you see GitHub having something where you can add all of the users into a single space and having them all collaboratively coding on one piece of code, rather
Oh.
than pushing and pulling back and forth, where some people are maybe doing.
Not cool quite,
the
but you
same
could
work.
look into, there's something called code spaces on GitHub that's a little bit in that vein, so that's worth checking out.
Okay, thank you.
And then last question.
Yeah, so mine is more of a conceptual question. This a sort of full crest stuff makes me feel like the way it's set up is that branches are meant to be like tests and you like look at different ways code might work, but then you like use the main branch.
Yeah.
Is it very inadvisable to use the branch sort of, or does anyone do this? To use the sort of branch framework to like just store different versions of the code that you want to use for different projects, like with slight alteration?
I think it's similar to that question in the sense that now you have trouble syncing up things, right? You'll always have to sort of, oh, what if somebody fixed a bug on the main branch and it's not on your branch and now you have to sort of merge things. So I prefer to sort of think of this all kind of flowing into the same development upstream eventually. Because
Yes.
conceptually it becomes very tricky to keep track of like, oh, I did this branch for this purpose and that branch. Rather, I'd think, okay, if I have different purposes for the code, let me make different modules that do these different things and keep it all in the same kind of main branch. Maybe that helps. We're past time here already, so maybe let's break here and there'll be plenty of time to answer a lot more of these questions later on. And then we'll resume at 3:30 in the Alder Auditorium with Nicolas.